So as I was saying, a word of caution is make sure that you spell your variables exactly the same how they appear in your data. So let's go to the data. And you can see that all my G's are capitalized. So I need to capitalize them, not include any spaces between G and a number. Same for my sense of self scale. SOS is capitalized. There are no spaces. So I need to specify them exactly the same way. So master goal factor, then performance goal factor would go on a new line. It doesn't matter whether you have spaces or not. So this is fine, this is fine. I just like including spaces. But each new command or each new factor or regression should be included on a new line. So performance goal has also 3 indicators. They are G4, G5, G6. And academic identity includes 5 indicators. SOS1, SOS2, SOS3, SOS4, SOS5. So it's absolutely fine that I didn't include the spaces. This is our measurement model. You can also include a hashtag, a sign, and spell out measurement model CFA portion. This text that you include after the hashtag will not be read by the program as a statistical command. So next, we can also include the same information. Let me switch my language. I'm not sure what happened here. I need to be in English. So hashtag, I'll be specifying structural model, or these are your path, or they could also be called regressions. So we will be predicting multiple goal with academic identity. Performance goal is predicted by academic identity, and then GPA, which is our observed variable, so it was not included in the measurement portion of this syntax, would be predicted by all master goal, performance goal, and academic identity. So I need again spell them in exactly the same way. It's sensitive to capitalization. So MG plus PG plus academic identity. I'm not including any correlations among my error terms, so I will just leave them be. And that's the syntax for our SEM model. So in order to run the model, you would press Ctrl and Enter. If there are any problems, for example, if you misspelled something, like you didn't capitalize it, and now I'm pressing Shift, Ctrl, Enter, you see I'll get an error message here, and it just drew my attention that this variable does not exist, so I need to correctly spell it. So if I'm pressing Ctrl, Enter, all my the model is applied and all my results show up here. By default, you'll only have 2 tables. One table will show you chi-square for your model, and the second table will show you parameter estimates. First, it will list the factor loadings. So remember, this was symbols for the confirmatory factor analysis. So these are the unstandardized estimates, and these are the standardized estimates so standardized factor loadings. These are the values essentially that we were focusing on yesterday. And then we have our dependent variable, our outcomes, and our predictors. Same thing, the unstandardized estimates are listed in the first column. Significant level is listed in the column for P, and the standardized estimates are listed in the second to the last column. So very briefly looking, you can see that academic identity predicts mastery goal. Academic identity also predicts performance goal. Mastery goal does not predict GPA, but performance goal predicts GPA and academic identity predicts GPA. So that's pretty much it in brief. The rest of the model includes the variance component for items, and at this point you can disregard it. But let me show you additional options that you should specify in your input. So let's take a look at statistics. I do want to include additional fit measures, so this will include the fit indices about which we spoke during our day 2 class. You can also include R-squared. Those are the percent of variance explained in each of the outcome by the predictors. Let's see what I usually check as well. We didn't really cover modification indices, but these modification indices can help you with like exploring where the model were misspecified in order to improve the model fit. Let's just keep it out. And then Mardias coefficient is statistics for multivariate normality. So if it shows that there is multivariate non-normality, you would calculate error using robust error estimation. So you would use this one. Again, because we are only doing the introduction, I will keep this unchecked. But I wanted to briefly mention them. So let's take a look at options. We're not doing any group in a variable, so we can also skip it. And the rest looks good. Here, estimators, we kept it at automatic, but maximum likelihood is very frequently used with continuous data. If you have categorical data, then, and not just categorical data, but categorical outcome, then you would use weighted least square estimation method and others. You would need to look in the literature and see which estimation method is the most appropriate for that specific data. Finally, under advanced options, you can also take a look at these options here. I actually want to include path diagram and show standardized parameters. So let's take a look at what additional tables we obtained here. So again, the chi-square test statistics for model 1, degrees of freedom 50, chi-square 167.752, and it's significant. Just like I mentioned yesterday, it's very rarely that in social sciences chi-square would be non-significant. We have again parameter estimates table without regression coefficients, and it's the easiest to look at standardized results because they're the easiest to interpret. and then these are our additional statistics. So chi-square model test baseline model. Chi-square is the same as it was in initial table. User model versus baseline model. So these are our fit statistics. You're familiar with CFI and TLI, so they are above 0.90, showing that the model fit was adequate. We did not cover all these indices, so it's possible to just disregard them at this point. This information, AAC, BAC, and sample size adjusted BAC, could also use to compare models. Again, we're not doing that. Here is our RMCA value. It's a 0.09. You can see that it's a little higher than it should be, or a little higher than what we would really like it to see. And here is our SRMR, our standardized root mean residual, and it's below 0.08, so within recommended norm. So taken together, CFI, TLI, and SRMR indicated that the model is adequate. RMCA suggested that perhaps there is some misspecification, but because most of these fit indices showed adequate fit, I'm quite satisfied, and I will not be making any adjustment to the model. These are squared, so you can see that about 15.8% of the variance was explained in GPA by our predictors. I'm not sure why these two variables are not displayed, but one of them is mastery goal and one of them is performance goal. Finally, this is our path diagram. You can see that as we specified, academic identity was specified to predict mastery and performance goal, and all three of these variables were specified to predict GPA. And there's you almost cannot see this line, but there's this line here. These are three latent variables, so they're denoted by ellipses or circles. We have our observed items, 5 items for sense of self or academic identity, 3 items for mastery goal, and 3 items for performance goal. And our final outcome, GPA, was an observed item, so that's why it's denoted by a rectangle or a square. And all our factor loadings here and here and here, as well as our path coefficients, are displayed in this figure as well.